Let's see some more examples on area. You want to find the area common to the parabolas. Y equal to 2x square and y equal to x square plus 4. First of all, let us quickly find the point of intersection of the two curves. Let me put y equal to 2x square here. What do I get is that gives me x square equal to 4 and x is plus or minus 2. If you substitute over here, get y will be 8. So the point of intersection are 2 comma 8 and 2 comma minus 8. Keep this in mind. The point of intersection of the two curves is 2 comma 8 and 2 comma minus 8. Y equal to x square plus 4 will be same as x square equal to y minus 4. The vertex at 0 comma 4. And of course, y equal to 2x square is a standard parabola. So let us see first y equal to 2x square. The standard parabola like this. And the second parabola, which is x square equal to y minus 4, has a vertex at 0 comma 4. And obviously this is also curving upwards because it is x square equal to ky. Sorry, they meet at 2 comma 8 and minus 2 comma 8, not 2 comma minus 8. Y is always 8, right? So 2 comma 8 and somewhere over here it will be minus 2. This is the, let me redraw the figure. This is the parabola y equal to 2x square. Second parabola, this point is minus 2 comma 8, this point is 2 comma 8, and this parabola is as simple as this. Just take a strip. Now you want to find area. You can see it is symmetrical about both the axes. So you take one strip on the right hand side and double it. You should be able to get the required area. So the required area will be 2 times from 0 to 2 2 times because this and this is symmetrical. What is the upper limit? Upper limit is this y. which is x square plus 4 minus lower limit is 2x square. So solve this, we will get 4 minus x square between 0 to 2. And the answer will be 32 by 3. Let us do one more sum. The area between y equal to 6x minus x square and y equal to x square minus 2x. First of all, let us solve these two equations simultaneously and see what we get. Compare y coordinates. And that gives you 2x square equal to 8x. That is x equal to 0 or x equal to 4. So if you put x equal to 0 and x equal to 4 in one of the equations, you get the y coordinate. Put x equal to 0 here, and if you put x equal to 4 here, you get 16 minus 8. You can put x equal to 4 here also. You will still get 24 minus 16, that is still 8. So the points of intersection are 0, 0 and 4, 8. Keep this in mind. These are the points of intersection. Now let us trace the two curves. First curve is minus or complete the square and you get the vertex of this curve will be 3, 9. It will be of the type x square equal to minus y. See the second curve. Complete the square. You get so this is of the type x equal to y and the vertex is 1, minus 1. So we have x square equal to minus y with 3 comma 9, x square equal to y with 1 comma minus 1, and the point of intersection are 0 comma 0 and 4 comma 8. So we have to now comprehensively draw these two curves. This is say 3 comma 9 and x square equal to minus 1. Where does the curve cut x-axis? You put y equal to 0. If you put y equal to 0, you get x minus 3 bracket square is 9. So the curve cuts x-axis at either x equal to 0 or x equal to 6. This is x equal to 0 and this is x equal to 6. Look at this curve now. X square equal to y curving upwards, having a vertex at 1 comma minus 1. Where does the curve cut x-axis? You put y equal to 0. You get x minus 1 is equal to plus or minus 1. Put y equal to 0 here. You get x minus 1 bracket square is 1. So x minus 1 is plus or minus 1. So either x equal to 2 or x equal to 0. So 1 comma minus 1 will be somewhere over here. X equal to 0. It's very tricky actually. Draw these curves is not an easy thing. X equal to 2 will be somewhere over here. In this. And what are the points of intersection? Let us see the points of intersection. What were they? Zero comma 0 and 4 comma 8. So this is 0 comma 0 and 4 comma 8 will be somewhere over here. So these are two parabolas. This is the upper and this is the lower. So this upper parabola is y equal to 6x minus x square, and the lower parabola is you take a simple strip like this, This is the point of intersection, which is x equal to 4, and this is x equal to 0. So the required area will be from 0 to 4. The upper y is 6x minus x square minus lower y is x square minus 2x. That gives the required area as 8x minus 2x. And the answer will be 64 by 3. Okay. Now let us do a typical sum on modulus functions. Find the area of the region bounded by the curve y equal to mod x minus 1, and these are tricky sums. Modulus function is not so easy to understand. So first of all, please note that we have to find out first when x is 0. This particular thing is 0, y becomes 0 when x equal to 1. To the left of x equal to 1, say x equal to minus 2, the expression is negative. But we want the answer to be positive because it is a modulus function. So for x less than 1, the curve will be minus of x minus 1. And for x greater than or equal to 1, y will be x minus 1. Similarly, in this case, mod x becomes 0 at x equal to 0. So at x less than 0, y will be 3 minus and mod x will be minus x. And for x greater than or equal to 0, you have y equal to 3 minus x. So you have to plot these 4 lines. You have to plot the line y equal to 1 minus x. You have to plot the line y equal to x minus 1. You have to plot the line y equal to 3 plus x. And you also have to plot the line y equal to 3 minus x. This line will be valid only for x less than 0. This line will be valid for x greater than 0. This line will be valid for x less than 1. And this line will be valid for x greater than 1. So first of all, let us plot these lines and then we will erase the things. Let us first plot y equal to 1 minus x. When x is 0, y is 1. And when y is 0, x is 1. So this is the line y equal to 1 minus x. Now let us see y equal to x minus 1. When x is 0, y is minus 1. And when y is 0, x is 1. This is the point 1 comma 0. This is the point 0 comma 1. Okay. Let's see the line y equal to 3 plus x. When x is 0, y is 3, which is somewhere over here. And when y is 0, x is minus 3, somewhere over here. Now let us see the line y equal to 3 minus x. When x is 0, y is 3, which is this point only. And when y is 0, x is 3. X equal to 3 will be somewhere over here. Now let us see the validity. Y equal to 1 minus x is valid for x less than 1. This is y equal to 1 minus x. It is valid for x less than 1. So x less than 1 is this region. So this region is not to be considered. Forget about this region. Now y equal to x minus 1 is valid for x greater than 1. This is the line y equal to x minus 1. It is valid for x greater than 1. This is x equal to 1. So for x greater than 1 means it is only this region which is valid. This region is not valid. So let us remove this region. I hope you are following what I am doing. Let us see this y equal to 3 plus x. Y equal to 3 plus x is valid for x less than 0, that is left of x-axis. 3 plus x is valid only in this region, that is left of x-axis. So this particular region is not valid. So get rid of this. And the last part, y equal to 3 minus x is valid. You can see here. For x greater than 0, that is right of x-axis. Means this region. So now you can see you get a rectangle. You get quadrilateral, not necessarily rectangle. What are the vertices? This is 3 comma 0. This is 1 comma 0. We have to find out the coordinates of this point of intersection. Y equal to 1 minus x and y equal to 3 plus x. Excuse you, let me quickly calculate. Gives me 2x equal to minus 2. So that gives me x equal to minus 1. If you put x equal to minus 1 here, you get y equal to 2. So this is minus 1 comma 2. Let us see this quickly. This is y equal to 3 minus x. This is y equal to x minus 1. To x equal to 4, that gives you x equal to 2 and y equal to 1. Now please understand, 3 plus x and 3 minus x product slope is minus 1. Similarly 1 minus x and x minus 1 product slope is also minus 1. So this is a rectangle. This angle is 90 degree. All these angles will be 90 degree. Otherwise what you can do is, you can split this rectangle into two areas and use the formula of determinants. That is one thing. Or you can simply use a distance formula to find this distance, and do length into breadth. That is what I am going to do. If you use the distance formula over here, 3, 0 and minus 1, 2, the answer will be root of 3 minus minus 1, that is 4 square, that is root 20. And if you consider this, it's 4 plus 4, that is root 8. So the area will be calculation. I don't know what mistake I have made. Sorry. This is 5. Please do the calculation. 3 minus minus 1 is 4. 4 square is 16. And 0 minus 2 is 2. If you see this length, this is 3 minus 2 is 1 plus 1. I don't think it's a rectangle. No. What is this length? 2 minus minus 1, that is 1 plus 1. So this is root 2, sorry. This length is root 2. This is not 3, 0, my mistake. This is 0, 3. That is why I have made a mistake. Just find this. 2 minus minus 1 is 1. So this is root 2. And if you find this length, so minus 1 minus 1. And 2 minus 0 is 2 cos square is also. So this is root 8 into root 2. So total area will be root 16. Is 4. So this is a typical example for modulus function. We will see other examples in our next session.